let your breathing settle into its own quiet rhythm. There is nothing you need to solve, remember, or understand completely tonight. You can simply rest here while distant worlds turn beneath unfamiliar stars. Perhaps the room around you already feels a little softer. Perhaps the sounds of the day are beginning to fade into the background. If your eyes feel heavy, you can let them close. The story will keep moving softly, carrying you far beyond the familiar sky. Tonight, we will travel through skies that no human being has ever stood beneath. Some may glow red, others gold, blue, violet, or almost completely dark. Some may hold two suns, while others remain forever suspended between day and night. Each sky would be shaped by its star, its atmosphere, its clouds, and the ground below. Even on Earth, the sky is not truly blue by itself. Sunlight enters our atmosphere and meets tiny molecules of nitrogen and oxygen. Shorter blue wavelengths scatter more strongly than most longer wavelengths. That scattered light reaches our eyes from every direction, creating the blue dome above us. On another planet, different gases and particles could scatter light in entirely different ways. A clear alien sky might appear turquoise, amber, pale green, or deep violet. Its color would depend on both the atmosphere and the light of its star. Around a red dwarf star, daylight might feel warmer and dimmer than daylight on Earth. Red dwarfs produce more of their visible light at red and infrared wavelengths. A planet beneath one could receive a soft copper glow rather than bright white sunlight. Yet the sky would not necessarily be red. Atmospheric molecules and floating particles would still transform the incoming starlight. A red dwarf planet with a thin, clear atmosphere might have a dark, bluish sky. Its small star could shine like a reddish lamp through the upper air. Near the horizon, scattered dust might turn the light into muted shades of orange and rose. Red dwarfs are smaller and cooler than the sun, but they can live for extraordinary lengths of time. Some may continue shining for trillions of years. Their planets could watch the same quiet red sun for longer than our universe has existed so far. Many planets close to red dwarfs may become tidally locked. One side would always face the star, while the opposite side remained turned toward space. The sun might appear almost motionless above one part of the landscape. There would be no ordinary sunrise or sunset in that region. Instead, the star would hang in one place, glowing steadily through the atmosphere. Clouds could drift beneath it, making the light brighten and dim without changing direction. On the night side, the sky might never know daylight. Stars could remain visible for years, centuries, or much longer. A traveler moving toward the boundary between day and night would enter a region of endless twilight. This boundary is sometimes called the Terminator. There, the star would rest close to the horizon, neither fully rising nor fully setting. Long shadows might stretch across the surface in the same direction every day. The sky could remain painted with sunset colors that never completely fade. There is no need to hold on to every detail. You can let the facts drift past you like thin clouds in a quiet atmosphere. On some tidally locked worlds, strong winds could carry heat from the day side toward the night side. The atmosphere might soften the difference between permanent sunlight and permanent darkness. High clouds could gather beneath the fixed star. Those clouds might reflect part of the incoming light back into space. From the surface, the star could appear behind a pale, luminous veil. Farther away, The twilight region might hold long bands of clouds moving around the entire planet. Some alien skies may belong to worlds with two stars. A planet in a binary system could orbit both stars together. From its surface, two suns might cross the sky in a slow celestial dance. They could appear close together on some days and farther apart on others. One might be bright and white, while the other glowed orange or red. The combined light would create unusual shadows. A person standing beneath them might cast two faint shadows pointing in different directions. As the stars moved, those shadows would lengthen, overlap, and quietly separate. A double sunset might not happen as a perfectly matched pair. One star could sink below the horizon while the other remained above it. The sky might dim halfway, pause in a long copper twilight, and then darken again. On another evening, both stars could descend close together. Their colored light might blend into layers of gold, peach, rose, and violet. If the two stars had very different temperatures, the landscape could subtly change color throughout the day. A hotter star would add more blue-white light. A cooler companion would contribute warmer shades of orange and red. Clouds might appear cream-colored under both stars, then turn pink when only the cooler star remained. Some planets could orbit one star, while a second star shone far away. That distant companion might look like an unusually bright point in the sky. It could remain visible during daylight, much like Venus sometimes appears from Earth. At night, it might cast a faint glow across clouds, ice, or oceans. Such a world could have a familiar sunrise from its nearby star. Yet its nights would never feel entirely solitary. A second sun would wait among the constellations, too distant to warm the surface greatly. Alien skies could also be shaped by thick atmospheres. On Venus, the surface lies beneath an atmosphere far denser than Earth's. Its clouds are so extensive that the sun would appear as a blurred brightness rather than a sharp disk. A similar exoplanet might experience daylight as a gentle, glowing ceiling. The sky could remain yellowish, cream-colored, or orange beneath layers of haze. Shadows would become soft and indistinct. Morning might arrive, not as a visible sunrise, but as a slow brightening of the clouds. Evening would be a gradual fading, with no clear moment when the star disappeared. A thick atmosphere can scatter light through many directions. This can make twilight last longer than it would beneath a thinner sky. On a dense alien world, the horizon might glow well after the star had set. The upper atmosphere could continue catching sunlight while the ground entered darkness. For a while, the clouds might shine from below like quiet lanterns. Some planets may have atmospheres filled with hydrocarbon haze. Saturn's moon, Titan, offers a nearby example. Its thick orange haze hides the distant sun and gives the surface a dim amber daylight. On a warmer world with similar chemistry, the sky might resemble endless golden dusk. Complex carbon-based particles could float high above the surface. They would absorb and scatter different colors, filtering the star into a muted glow. The landscape beneath might appear soft-edged, as though seen through old honey-colored glass. Distant mountains could fade quickly into the haze. A nearby lake or sea might reflect only a pale patch of light. If your eyes feel heavy, you can let them close. The strange skies will continue turning quietly, whether you watch them or not. Clouds on other worlds need not be made of water. Different temperatures allow different materials to condense into droplets or crystals. On very hot planets, clouds may form from substances that are solid minerals on Earth. Silicate particles could gather into high clouds. From far away, these clouds might look bright and pale, much like ordinary clouds. Yet each tiny particle would be more similar to powdered rock than frozen water. Iron could also condense in the atmospheres of extremely hot worlds. In some regions, metallic droplets might form and fall deeper into the atmosphere. The upper sky could contain dark mineral clouds illuminated by an enormous nearby star. These conditions sound dramatic, but from a great distance they might appear calm. A telescope could see only a softly changing pattern of brightness. Cloud bands would drift across the planet, slowly altering the light it reflected. On cooler gas giants, clouds may form from ammonia, methane, or other compounds. Their skies could be layered into many levels. The highest clouds might glow white under distant sunlight. Lower layers could appear blue, gray, brown, or muted green. A floating observer would not see a solid surface below. Instead, cloud decks could continue downward into thicker mist and increasing pressure. Above, the sky might darken gradually toward space. Below, the atmosphere could become an endless ocean of vapor. Winds on giant planets may organize clouds into long bands. Some bands move east, while neighboring bands move west. From within the atmosphere, these patterns might resemble vast rivers in the sky. Thin clouds could stretch farther than entire continents on Earth. Their edges might curl slowly into spirals and waves. On a quiet day, the motion could be almost impossible to notice. Only after hours would the cloud formations reveal how far they had traveled. Auroras may brighten many alien nights. On Earth, auroras appear when charged particles interact with our magnetic field and upper atmosphere. Different gases emit different colors when energized. Oxygen can produce green and red light, while nitrogen contributes blue and violet tones. An alien atmosphere with other gases could create unfamiliar auroral colors. The patterns would also depend on the planet's magnetic field. A stronger field could guide charged particles into large glowing ovals around the poles. On some worlds, auroras might be visible across much of the planet. They could form broad curtains, arcs, and softly pulsing ribbons. A moon orbiting inside a giant planet's magnetic environment might experience frequent auroral displays. The sky could brighten whenever particles flowed along invisible magnetic paths. From the moon's surface, the giant planet might fill a large part of the heavens. Above it, luminous bands could ripple silently through the upper air. There is no sound in an aurora itself at such distances. Its motion would be entirely visual, slow and weightless. The story will keep moving softly in the background. You do not need to follow every world to its horizon. Some alien sunsets may be blue rather than red. Mars gives us a gentle example of this reversal. Fine dust in the Martian atmosphere scatters red light widely through the daytime sky. Near sunset, more blue light remains concentrated around the sun. The result can be a cool blue glow surrounding the setting star. An exoplanet with similar dust could have rust-colored afternoons and blue evenings. The horizon might deepen into indigo as the star disappeared. High clouds could catch the last light and shine in delicate silver-blue layers. On another planet, larger particles might scatter light almost evenly. Its sky could appear pale or milky throughout the day. The star might sit inside a broad white halo. Sunrise would begin as a brightening circle within the haze. The disk itself might emerge only when it climbed higher. Other atmospheres could be remarkably clear. With little gas and almost no dust, the daytime sky might remain nearly black. The star would shine sharply against the darkness. Stars might stay visible even while the ground was brightly illuminated. Our moon offers something similar because it has almost no atmosphere. On a clear, thin-aired planet, daylight and starlight could share the sky together. A blue-white sun might blaze overhead. Around it, constellations would remain fixed in the blackness, faint but present. The horizon would have little glow. Day would end quickly once the stars slipped below the landscape. Then the surface would enter a darkness filled immediately with stars. Some nights would be illuminated by enormous moons. A close moon could appear many times wider than Earth's moon. Its surface features might be visible without any instrument. If covered in ice, it could cast a cool, powerful light over the landscape. If covered in dark rock, it might look like a silent shadow against the stars. A planet with rings would offer another kind of sky. From certain latitudes, the rings might stretch from one horizon to the other. They could appear as bright bands made of countless icy particles. During the day, they would reflect the star's light. At night, they might glow softly while the planet's shadow darkened one section. The rings could cast shadows onto the atmosphere and ground. As the seasons changed, those shadows would shift slowly. At some times, the rings might appear wide and brilliant. At others, they would narrow into a thin line crossing the sky. No two alien skies would need to look exactly alike. Every atmosphere would be a quiet record of temperature, gravity, chemistry, clouds, and light. And every star would paint those ingredients in its own colors. For now, you can imagine resting beneath one of those distant heavens. A small red sun waits above the horizon, surrounded by copper clouds. Behind you, the night side begins, calm and filled with stars. Ahead, the daylight remains warm but gentle. Between them lies a narrow country of endless evening. Nothing in the sky seems hurried. The clouds travel slowly. The light changes softly, and the planet turns without asking to be noticed. There is no need to hold on to every detail. You can let these unfamiliar skies become simple colors, drifting quietly into sleep. Beyond the world of endless twilight, another planet turns slowly beneath a brighter, whiter star. Its daylight feels clear and silvery, touching every cloud with a faint blue edge. Hotter stars release more blue and ultraviolet light than our sun. Beneath such a star, the landscape might appear cooler in color, even when the surface itself is warm. White clouds could shine brilliantly against the deep blue or violet sky. Shadows might carry a soft bluish tone, especially where reflected light is weak. The star could look smaller than our sun if the planet orbited far away, yet its greater brightness might still fill the atmosphere with intense pale daylight. A thicker ozone layer or another protective gas could absorb much of the ultraviolet radiation above, from the ground. This upper layer might remain invisible. It would simply be part of the quiet chemistry that makes the lower sky gentler. Around a cooler orange star, daylight could feel more familiar. Orange stars are smaller and longer lived than the sun, though brighter than most red dwarfs. Their light may give pale surfaces a slightly warmer appearance. Snowfields could look cream-colored beneath them. Clouds might glow like soft apricot in the late afternoon. The sky itself could still appear blue if the atmosphere scattered shorter wavelengths sufficiently. A blue sky beneath an orange sun would create a beautiful contrast. The star would move through the blue dome like a small amber coin. At sunset, the entire horizon might deepen into bronze and muted rose. Planets around orange stars are especially interesting because these stars can remain stable for very long periods. Their skies might change gradually across billions of quiet years. Continents could shift, atmospheres could evolve, and oceans could appear or disappear. Yet the orange star would continue rising with almost the same steady light. There is no need to remember the names of the stars. You can simply notice their colors, then allow them to fade gently into one another. On some planets, the atmosphere could bend light strongly near the horizon. Earth's atmosphere already does this through refraction. It makes the setting sun appear slightly higher than its true position. A denser alien atmosphere could create a much stronger effect. The star might appear flattened, stretched, or divided into shimmering layers as it approached the horizon. It could seem to pause before setting. Its lower edge might disappear, while its upper edge remains suspended in the air. In unusual conditions, more than one image of the star could appear. A distant sun might become two faint disks stacked above the horizon. These would not be separate stars, but light following different curved paths through the atmosphere. The effect could change slowly as temperature shifted between layers of air. A traveler might watch the false suns merge into one and then dissolve into evening. Dense atmospheres could also allow someone to see slightly beyond the ordinary horizon. Light from distant terrain might curve through the air. Mountains normally hidden by the planet's roundness could appear as pale, floating shapes. They might seem detached from the surface, resting quietly inside the haze. The same bending could lengthen sunrise and sunset. Morning light could arrive before the star itself became visible. Evening light could remain long after it had physically moved below the horizon. On a small planet with weak gravity, the atmosphere might extend far into space. Its upper layers could create a broad halo visible from the surface. Just before dawn, this halo might glow around the entire eastern horizon. At night, faint airglow could trace the curve of the world. Airglow is a gentle emission produced by atoms and molecules high in an atmosphere. Earth has it too, although it is usually too faint to notice from bright places. On a darker alien world, airglow might be a familiar part of every night. Then green, red, or violet bands could hover above the horizon. Unlike auroras, they might form smooth layers rather than moving curtains. The glow could remain nearly still for hours. It would be a quiet reminder that even darkness contains chemistry and light. Some atmospheres might glow more brightly after strong daylight. Energy absorbed during the day could be released slowly at night. The upper sky might seem to remember the star after sunset. A faint radiance could continue while the ground cooled beneath it. There would be no need for moons or artificial lights. The atmosphere itself would provide a dim, natural night lamp. On another world, clouds could cover the planet completely. No stars would be visible from the ground. The sky would be a continuous ceiling of gray, blue, or golden vapor. Yet even such a sky would have its own changing beauty. Waves might travel through the cloud layers. Lighter patches could form where the clouds became thinner. At noon, a bright region would mark the hidden star's position. At evening, the whole ceiling would slowly darken from one side to the other. A moon above the clouds might create a wide circle of pale light. Its disk could remain invisible, but its glow would move across the cloud deck. Occasionally, crystals inside the clouds could create halos. A ring might appear around the hidden star or moon. On Earth, ice crystals produce pillars, arcs, and circles of light. Alien crystals with different shapes could make unfamiliar patterns. The sky might display several delicate rings crossing one another. Small points of light could appear beside the star, like quiet companions. They would be optical effects rather than real objects. Still, to someone living beneath that sky, they might become familiar signs of weather. There is no need to hold on to every detail. The facts can pass like reflections across a high cloud layer. Some planets may have very deep atmospheres without a solid surface nearby. Far above the dense lower regions, floating clouds could occupy a calm band of pressure and temperature. From there, the sky above might look blue, gray, or nearly black. Below, Cloud layers would hide the deeper atmosphere. The horizon might curve gently in every direction. A distant star would rise through thin upper haze. Its light could cast enormous shadows across the cloud tops. Because the observer was floating, there would be no mountains or trees to measure those shadows. Only slow-moving cloud forms would reveal the passage of time. Large, buoyant organisms are sometimes imagined in such atmospheres. Science does not yet know whether anything like them exists, but the physical idea of floating within a dense atmosphere is possible. A living world would not always need a firm ground beneath its sky. Its weather, light, and chemistry could all unfold within layers of air. Higher above, tiny particles might remain suspended for months. They could form thin veils that circle the entire planet. After passing through them, starlight might become softened and reddened. The star could appear surrounded by a wide, glowing disk. At night, those particles might scatter light from rings, moons, or nearby planets. The darkness would never become entirely empty. On worlds with active geology, fine dust could enter the atmosphere naturally. If the dust remained high and thin, sunsets might become especially vivid. Each particle would scatter and absorb part of the incoming light. The resulting colors would depend on the particle size and mineral composition. Iron-rich dust could strengthen warm red tones. Pale silicate dust might create softer cream and pink shades. Dark carbon particles could mute the entire sky. A sunset there might resemble light passing through smoke-colored glass. Yet the scene could remain quiet and still. The dust would drift invisibly while the star slowly descended. Some planets may have oceans covering almost their entire surfaces. Above a global ocean, the horizon would be smooth and uninterrupted. Clouds could travel for thousands of kilometers without meeting mountains. Storm systems might form broad spirals visible across enormous distances. On calmer days, the water would mirror the sky from horizon to horizon. A red dwarf could create a copper path across the sea. A white star might leave a silver trail. Two stars could produce two reflections that crossed and separated with the waves. If the atmosphere were humid, low clouds might form close to the water. The horizon could dissolve into mist. Sky and ocean would become difficult to distinguish. Only the stars above and the soft movement below would reveal which direction was which. A planet with lighter gravity might produce taller waves and slower falling spray. Droplets could remain in the air longer. Around sunrise, each one might catch the light. A fine mist could fill the lower sky with thousands of faint points. From far away, the effect might look like a glowing layer resting upon the ocean. On colder ocean worlds, the surface could be covered by ice. Cracks and smooth plains would reflect the sky differently. A nearby giant planet might rise above the frozen horizon. Its bands and clouds could be visible without a telescope. The giant might appear larger than any moon seen from Earth. Over several hours, it would move slowly across the sky. Its reflected light could turn the ice pale blue, amber, or cream. If the icy world were tidally locked to the giant, the planet might remain in nearly the same place overhead. It would grow slightly larger and smaller as the moon followed an oval orbit. Cloud patterns on the giant would change beneath the fixed shape. Dark bands would drift, bright storms would rotate, and the curved limb would catch distant starlight. At certain times, the moon might pass into the giant planet's shadow. Daylight would fade gradually as the star disappeared behind the enormous world. The sky would darken, and stars would emerge. Auroras might brighten near the horizon while the eclipse continued. Then a narrow line of light would return. It could spread slowly around the edge of the giant like a silver ring. These eclipses might happen regularly. To inhabitants of the moon, They would feel less like rare events and more like another gentle rhythm of the sky. Some exomoons could experience eclipses every few days. Their calendars might be built around darkness arriving at midday. Plants, if they existed, could respond by folding leaves or slowing their chemistry. Animals might become still until the light returned. The entire landscape could enter a short, familiar evening before continuing the day. The story will keep moving softly in the background. You may let the worlds come and go without following each one. On planets with long, tilted orbits, the sky could change greatly across the year. The star might appear larger during one season and smaller during another. Its brightness would increase as the planet moved closer. Months later, it would fade slightly as the world traveled farther away. Sunsets could become warmer and brighter during the close season. The atmosphere might expand as it heated. Cloud layers could rise higher, altering the color of the sky. During the distant season, the air might cool and become clearer. Stars could appear sharper at night. Some gases might even freeze out of the atmosphere and settle onto the ground. When warmth returned, they would slowly evaporate back into the sky. The atmosphere itself could therefore grow and shrink with the seasons. Pluto offers a gentle example within our own solar system. Part of its thin atmosphere can freeze onto the surface as it moves farther from the sun. On an exoplanet, this cycle might be much more dramatic. Winter skies could become dark and clear. Summer skies might fill with haze again. Each year would redraw the horizon. A world with an extreme axial tilt might experience the star circling low above the horizon for months. Near one pole, the sun might never fully set during summer. It would trace a slow ring through the sky. The light would move sideways rather than rising and falling. Shadows would rotate around stones and hills. Then the long polar night would arrive. For another season, stars would remain continuously visible. Auroras could drift above frozen ground beneath a motionless constellation. Between these seasons, sunrise might take many days. The star would creep gradually upward. The first light could begin as a thin glow and broaden across the horizon. Clouds would catch the growing brightness long before the surface warmed. A single morning might last longer than an entire Earth week. On rapidly rotating planets, the opposite could occur. Days and nights might pass in only a few hours. Stars would rise quickly and sweep across the sky. Cloud shadows would race over the landscape. Sunsets would be brief, though still gentle in their colors. The atmosphere might organize into many narrow wind bands. From the ground, high clouds could stream continuously from west to east. The pattern would repeat so often that daylight might feel like a slowly pulsing rhythm. Bright, dim, bright, dim. As clouds and night followed one another. A planet's rotation would also influence the path of its stars. Near the equator, constellations might rise almost vertically. Near the poles, they would circle without setting. If the planet rotated very slowly, the stars would seem nearly fixed. A person could watch one constellation remain above the same mountain for many nights. There would be time to notice every faint point. Meteors might cross some alien skies frequently. Small particles from comets or rings could enter the atmosphere. Most would burn high above the surface without reaching the ground. They might appear as fine lines of light. On a world passing through a dense stream of particles, dozens could become visible each minute. The display need not feel violent. From far below, it could resemble luminous rain. Different atmospheric gases might tint the meteor trails. Some could glow green, orange, violet, or blue. Long-lasting trails might twist slowly in upper winds. After the meteor itself vanished, a pale ribbon could remain. It would bend and fade over several minutes, revealing air currents too high to feel. there is no need to count the lights. You can let them cross the sky and disappear by themselves. Some skies may contain visible dust beyond the atmosphere. Our solar system has zodiacal light, created by sunlight scattering from dust between the planets. From a very dark place on Earth, it appears as a faint triangular glow. In a younger planetary system, much more dust might remain. The night sky could contain a bright band along the path of the planets. Before sunrise, this band might rise like a soft column of light. After sunset, it could linger above the opposite horizon. A planet near a dusty ring might see the entire sky crossed by a pale, luminous road. Moons and planets would move along it. Comets could leave quiet trails within the same broad glow. In some systems, neighboring planets might appear unusually large. Two worlds could pass close enough to show clear disks rather than points. Cloud patterns or surface colors might be visible to the unaided eye. One planet could shine blue, another gold, another soft white. Their positions would change from night to night. At closest approach, one might cast a faint shadow. Later, it would shrink again and return to the stars. The inhabitants of such a world, if any existed, might think of the neighboring planet as part of the landscape. It would rise behind familiar hills. It would reflect in lakes. Its phases would mark the passing months. A crescent planet could hang above sunset, much larger than Venus appears from Earth. Over time, the crescent would widen into a half-lit disk. Eventually, the planet would become full and bright in the midnight sky. Then the cycle would reverse. Every phase would reveal the geometry of distant sunlight. The sky would become a slow, visible clock. For now, imagine that large crescent resting above a quiet alien ocean. The local sun has already set, leaving a violet glow near the horizon. High clouds carry the last pale light toward the night side. Above them, the crescent world shines without flickering. A few meteors pass through the upper atmosphere. They leave thin trails that curl gently and disappear. Nothing needs to be remembered. Nothing needs to be reached. The planet continues turning, the clouds continue drifting, and the unfamiliar night remains calm. Far beyond the crescent world, another planet rests beneath a sky filled with pale violet haze. Its star is brighter than the sun, but the atmosphere softens every sharp edge. Daylight arrives as a cool glow spreading slowly across the horizon. The star itself appears small and white, surrounded by a faint blue halo. High clouds contain tiny crystals formed from unfamiliar minerals. They drift in long, thin layers, almost transparent against the upper sky. When light passes through them, delicate arcs appear around the star. Some arcs resemble circles, while others stretch upward like quiet pillars. Their shapes change as the crystals turn gently in the wind. A second ring may appear farther away, faint enough to vanish when directly observed. On Earth, ice crystals can create similar halos. On this world, different crystals might bend light into completely new patterns. The sky could hold soft crosses, curved bands, or floating points of color. None of them would be solid objects. They would simply be starlight finding several paths through the clouds. There is no need to hold on to every detail. You can let the lights form, change, and disappear without following them. As evening approaches, the violet haze deepens. The white star moves lower, becoming warmer in color near the horizon. Its light travels through more atmosphere, losing some of its cooler wavelengths. The star gradually turns pale gold, then amber, then muted rose. Above it, the sky remains lavender. Below it, the horizon becomes a narrow ribbon of copper. The mineral clouds catch several colors at once. Their upper edges glow pink, while their lower surfaces fade into blue-gray shadow. For a few minutes, the whole sky seems divided into quiet layers. Then the star slips behind the distant hills. The upper atmosphere continues glowing after the surface has entered night. This extended twilight might last much longer than an Earth sunset. A dense atmosphere can keep scattering light even when the star is no longer visible. The horizon would fade slowly, never changing all at once. Stars begin appearing first in the darkest part of the sky. They look slightly blurred through the remaining haze. One by one, they spread toward the brighter horizon. A small moon rises soon afterward. Its surface is covered with pale dust, reflecting the star's cool light. Through the violet atmosphere, the moon appears faintly blue. A thin ring of light surrounds it. This glow is created by tiny particles, scattering moonlight through the air. The moon moves slowly, taking many hours to cross the sky. Its gravity may pull gently on clouds, oceans, and the planet's outer crust. If there are seas below, their tides rise beneath the moon's silent path. From the shore, the water reflects a broken blue trail. Small waves stretch the reflection and gather it together again. Far overhead, the mineral clouds become almost invisible. Only their halos remain, revealing where the crystals are drifting. The moonlight passes through them and forms a wide silver circle. For a while, the night contains several layers of brightness. There is the moon, the halo, the fading horizon, and the faint glow of the atmosphere itself. None is bright enough to disturb the darkness. Together, they make the landscape feel softly illuminated. If your eyes feel heavy, you can let them close. The sky will continue changing quietly without needing to be watched. Later in the night, a distant planet rises. It appears as a steady golden point, brighter than the surrounding stars. Unlike the stars, it does not flicker much. Its light travels through the same atmosphere, but its tiny disk softens the effect of turbulence. Over several nights, it moves slowly against the constellations. No movement is visible from moment to moment. Only patient observation would reveal how far it has wandered. Near dawn, the golden planet stands close to the eastern horizon. The violet haze begins to brighten around it. At first, the change is almost too gentle to notice. The stars fade gradually, beginning with the faintest. The moon becomes pale and transparent against the returning light. High clouds reappear as silver threads. Then the hidden star touches the atmosphere below the horizon. A narrow glow spreads upward, soft blue above and warm rose below. The first direct light reaches the highest clouds. They shine before the ground does, floating in a sky that is still partly night. The golden planet disappears into the growing brightness. The moon remains a little longer, then fades as well. Soon, the white star rises again. Its halo forms within the mineral clouds, beginning another quiet day beneath an alien sky. The story will keep moving softly in the background. You may let this strange morning drift away as another distant world begins to turn. Beyond the violet world, a smaller planet turns beneath the quiet light of a red dwarf. Its star is dimmer than the sun, yet it fills the sky with a deep amber glow. The planet moves close to its star, completing each orbit in only a few Earth days. Because it is so near, gravity may keep one side facing the light. The bright hemisphere knows no ordinary evening. The dark hemisphere never sees a natural sunrise. Between them lies a wide region of permanent dawn. Here, the star rests low above the horizon. It never climbs high, and it never completely disappears. The landscape is covered by long shadows that remain almost unchanged. Hills glow softly on one side and fade into blue darkness on the other. The sky near the star appears copper and rose. Farther overhead, it deepens into dark violet. Behind the observer, stars are already visible. Day and night share the same sky without a clear boundary. There's no need to hold on to every detail. You can simply rest within this long, unchanging twilight. The atmosphere carries warmth from the dayside toward the night. High winds move steadily above the quiet ground. They form long cloud bands that circle the planet. Some clouds drift through sunlight and brighten along their edges. Others travel into darkness and slowly lose their color. A single cloud could begin its journey under permanent afternoon. Hours later, it might enter the twilight region. Eventually, it would cross into endless night. There, the cloud could cool and release snow or fine crystals. The particles might fall through a sky filled with stars. Closer to the warm side, they would evaporate and return to the air. In this way, the planet's weather could travel in a continuous circle. Water, vapor, ice, and cloud would move between light and darkness. Near the fixed star, a large cloud might remain almost permanently in place. Warm air would rise beneath the strongest light. As it rose, it would cool and condense. The result could be a bright cloud directly below the star. From space, this cloud might look like a white mark at the center of the day side. From the surface, it would soften the red sunlight. The star might appear only as a blurred crimson circle. Around it, the cloud would glow in shades of peach and gold. The permanent cloud could also reflect heat away from the planet. This might help keep parts of the surface cooler than expected. A world close to its star does not always need to be unbearably hot. Clouds, winds, oceans, and atmospheric circulation can change the balance. Farther into the twilight zone, the sky grows clearer. The red star remains low, surrounded by a thin orange halo. Its light passes sideways through the atmosphere. This long path makes the horizon glow more strongly. The upper sky stays dark enough for bright stars. A nearby planet may appear as a pale point above the red sun. It would be visible throughout the endless evening. Because the local star is small, its disk might not look much larger than our sun, yet its color would make the entire scene feel unfamiliar. Rocks could appear rust-colored beneath the warm light. Snow might look faintly pink. Dark plants, if they existed, could absorb the red and infrared light efficiently. Their leaves might appear purple, black, or deep brown. No one knows what alien plants would truly look like. Their colors would depend on chemistry, atmosphere, and available starlight. Still, a dim red star might favor surfaces darker than Earth's green forests. Those dark leaves could gather light during the permanent afternoon. Near the twilight region, they might grow slowly beneath the low sun. They would never experience a normal sunset. Their shadows would point in one direction for their entire lives. If your eyes feel heavy, you can let them close. The red sun will remain quietly above the horizon. On the night side, auroras could be especially easy to see. Charged particles from the star may travel along the planet's magnetic field. When they reach the upper atmosphere, the gases begin to glow. Broad green and violet curtains might spread across the dark hemisphere. Because the night never ends, the auroras would not wait for evening. They could appear whenever the magnetic sky became active. Some would be faint, almost like transparent clouds. Others might form wide rings around the planet's poles. From the twilight zone, one could see the last red light in one direction. In the other direction, auroras would ripple above the stars. The sky would hold sunset and midnight together. Far below the auroras, the atmosphere might produce a soft air glow. A thin band of green could follow the curve of the horizon. Higher above, violet light would fade into black space. The colors would remain silent. They would move without wind, sound, or heat reaching the ground. On the darkest plains, the fixed stars would become familiar landmarks. Constellations would not rise and set in the usual way. They would circle slowly around the sky. Some might remain visible for years without touching the horizon. A bright neighboring planet could shine steadily among them. It might show phases as it moved around the red star. At times, it would appear as a crescent. Later, it would become half-lit, then almost full. Its changing shape would be one of the few obvious clocks in the night. On the permanent day side, time would also be difficult to see. The star would not cross the sky. There would be no morning shadows or evening colors. Instead, people might watch the motion of clouds. They might count the passing of weather systems. They could notice distant planets shifting against the fixed background. The sky would still change, only more slowly. A planet does not need sunrise and sunset to have rhythm. Its atmosphere, moon, stars, and seasons can still mark time. The story will keep moving softly in the background. You can let this world remain forever between day and night. The red star stays low. The clouds continue their long journey around the planet, and the quiet twilight never needs to end. Far beyond the red dwarf world, another planet circles a pair of quiet stars. One star is pale gold, while the other glows with a softer orange light. From the surface, both suns rise close together. Their light blends across the morning sky, creating two overlapping halos. The brighter star climbs slightly faster. Its shadow appears sharp, while the second shadow remains warm and faint. As the day continues, the two shadows slowly separate. One moves toward the east. The other turns at a gentler angle across the ground. Clouds receive light from both directions. Their upper edges shine white beneath the brighter sun. Their lower layers glow amber beneath the cooler one. The sky may still appear blue if the atmosphere scatters shorter wavelengths strongly. Against that blue, the orange star would look especially warm. The golden star might seem almost white near the center of the sky. There is no need to follow every movement. You can let the two suns cross quietly above the clouds. On some days, the stars would remain close together. Their light would feel like one broad source of warmth. On other days, they would spread farther apart. One could approach the horizon, while the other remained high above. This would create a sunset in two gentle stages. The first star might descend behind distant hills. The landscape would darken slightly, but the day would not end. The second sun would continue shining through a quieter sky. Its light could turn the clouds, copper, rose, and pale gold. For a while, the world would rest beneath a half-finished evening. The sky near the first sunset would deepen into violet. Across the opposite horizon, daylight would still remain. A few bright stars might appear before the second sun had set. Then the orange star would begin its own slow descent. Its light would travel through thick layers of air. The disk might flatten near the horizon. Warm colors would spread through the lower clouds. When the second star finally disappeared, darkness would arise softly. The long double twilight could last much longer than sunset on Earth. High clouds would continue catching light from both stars below the horizon. Some might glow on one side and remain dark on the other. The sky could hold two fading bands of color. One would be pale gold, the other would be muted red. Gradually, both would dissolve into the night. If your eyes feel heavy, you can let them close. The stars will continue their slow dance without needing to be watched. A planet in such a system might sometimes see one star pass in front of the other. From the ground, the two disks would begin to overlap. The brighter star might slowly cover the orange one. For a few minutes, their combined light would change. The sky would dim slightly, shadows might sharpen as one source of light disappeared. Then the hidden star would emerge again from the opposite side. The entire event could happen without darkness. It would feel more like a quiet change in the color of daylight. At other times, the smaller star could pass across the face of the larger one. It might appear as a dark circle, moving slowly over a bright disk. The surrounding sky would remain calm. Only patient eyes would notice the careful movement. Clouds could briefly soften the event. A thin veil might hide both stars, then reveal them already partly separated. Because the stars orbit each other, their rising and setting times would change. Some mornings would begin with both suns together. Other mornings might bring the golden star first. The orange star could rise later, entering a sky already filled with daylight. For a while, the first sun would cast a single shadow. Then the second shadow would quietly appear. The sky would never repeat itself in exactly the same way. Its patterns would return, but with subtle differences. A double-star planet could also experience unusual seasons. The changing distance and position of the stars might alter the amount of light reaching the surface. Some years could have long, gentle summers. Others might bring cooler skies and more persistent clouds. The atmosphere would respond slowly. Cloud belts could shift toward warmer regions. Ice might expand or retreat. Haze could thicken during brighter seasons. These changes would unfold over many orbits. From one evening to the next, the world would still feel peaceful and steady. Near the coast, both suns would create separate paths across the water. The brighter reflection would appear silver gold. The second would stretch across the waves in orange light. When the stars stood close together, the two paths would nearly merge. When they moved apart, the reflections would form a wide, shining angle. Small waves would break each path into thousands of moving pieces. No single reflection would remain for long. Yet the larger pattern would continue following the stars. At night, the ocean would become dark and smooth. Two neighboring planets might then appear above the horizon. They would move around the same pair of stars. One could shine pale blue. The other might glow softly red. Their phases would change as their orbits carried them through different angles of light. Sometimes both would appear as crescents. Sometimes one would be nearly full while the other remained thin. Their steady light would reflect faintly on the sea. Above them, the constellations would look unfamiliar. Some stars might appear in pairs. Others would shine alone in the deep black sky. The local suns would be gone, but their warm colors would remain in memory. The story will keep moving softly in the background. You do not need to remember which star rose first. You can simply imagine the last orange light fading across a quiet alien ocean. The two suns are now below the horizon. The clouds have become dark silver. The planets shine gently above the water. And the double night settles into stillness. Beyond the double sunset, another world turns beneath a sky filled with deep blue clouds. Its atmosphere is rich in gases that scatter the star's light into cool shades. At midday, the sky appears almost indigo. Near the horizon, it becomes softer, fading into pale turquoise. The star is slightly cooler than the sun. Its light carries a gentle golden tone through the blue atmosphere. Clouds form in several layers. The highest are thin and silver. Lower clouds are broad, dark blue, and slow-moving. Between them, narrow openings reveal brighter patches of sky. Light passes through these openings like quiet columns. From the ground, The beams seem almost solid. They drift slowly as the clouds move overhead. There is no need to hold on to every detail. You can let the light pass gently through the clouds. Some of these clouds may be made from water. Others could contain droplets of methane, ammonia, or more unfamiliar compounds. Their appearance would depend on the temperature and pressure around them. A cloud can look soft and familiar even when its chemistry is completely different. Its edges would still brighten in sunlight. Its lower surface would still fade into shadow. Only a careful instrument might reveal what the droplets contained. Far above, stronger winds pull the clouds into long parallel bands. The bands stretch around much of the planet. From the surface, they look like wide roads crossing the sky. One layer moves east, another moves slowly west. Where they meet, the cloud edges curl into gentle waves. These waves may repeat for hundreds of kilometers. They rise and fall without ever reaching the ground. On Earth, atmospheric waves can create rows of evenly spaced clouds. An alien atmosphere could produce similar patterns on a much larger scale. The sky might appear carefully arranged, although no one had arranged it. At sunset, the deep blue sky begins to change. The golden star approaches the horizon. Its light passes through more air and becomes warmer. The turquoise horizon turns pale green for a few moments. Then it shifts toward yellow, amber, and muted orange. Above, the indigo sky remains dark. The result is a sunset with warm colors below and cool colors overhead. Thin silver clouds become pink along their lower edges. The darker clouds remain blue, creating wide shadows between the glowing layers. The star itself looks slightly flattened as it reaches the horizon. Atmospheric refraction bends its light. For a moment, the upper edge seems to remain after the lower edge has disappeared. A brief green or blue rim may appear. On Earth, this kind of flash is rare and delicate. On a world with a different atmosphere, it could be more common. The final light might appear as a thin turquoise line. Then the star would slip away. If your eyes feel heavy, you can let them close. The evening sky will continue changing softly. After sunset, the highest clouds remain illuminated. They float in darkness while still catching sunlight from beyond the horizon. Their silver color slowly becomes pale violet. Lower clouds fade into dark blue. For a while, the sky contains both night and day in separate layers. Stars appear between the clouds. At first, only the brightest are visible. Then smaller points begin to fill the clear spaces. The moving clouds hide and reveal them. A constellation may appear for several minutes. Then a dark cloud passes, and the pattern disappears. Farther west, the last sunset colors remain. They form a narrow green-blue glow above the horizon. This glow becomes fainter, but lasts for a long time. The atmosphere is thick enough to scatter light after the star has set. A small moon rises through the remaining color. It appears pale yellow near the horizon. As it climbs, it becomes whiter. The moon passes behind several cloud layers. Sometimes, it is sharp and clear. Sometimes, it becomes a blurred circle inside a glowing mist. Around it, a wide halo forms. The halo is produced by crystals high in the atmosphere. Its inner edge is bright. Its outer edge fades gently into the dark sky. A second, fainter ring may appear beyond the first. Moonlight touches the upper clouds and gives them a soft silver outline. The lower clouds remain nearly black. They move slowly beneath the brighter layers. The moon seems to drift in the opposite direction, although it is the clouds that are moving. This quiet illusion could last for hours. On the ground, lakes reflect broken pieces of moonlight. Each opening in the clouds creates a different patch of brightness. Dark lake may become silver for a moment. Then another cloud arrives, and the water returns to black. The changes are gradual. Nothing in the landscape means to hurry. Later in the night, the atmosphere begins to glow faintly. A thin, blue-green band appears near the horizon. It is not sunrise. It is air glow produced high above the surface. Atoms release small amounts of stored energy. The glow is far dimmer than moonlight. Yet beneath a dark sky, it can still be seen. The band follows the curve of the planet. Above it, stars remain bright. Below it, the clouds move like dark islands. Auroras may sometimes join this quiet light. They begin as a faint arc near the northern horizon. The arc grows wider and slowly rises. Soft curtains form beneath it. Their color is pale violet and green. They do not flash suddenly. They brighten and fade in long, gentle waves. The moonlight, air glow, and aurora overlap. Each comes from a different part of the sky. The moon reflects distant starlight. The air glow comes from the atmosphere itself. The aurora follows the invisible magnetic field. Together, they make the alien night softly luminous. The story will keep moving quietly in the background. You may let the colors blend without naming them. Near dawn, the clouds begin to lose their darkness. The eastern horizon becomes deep blue. A thin turquoise line appears beneath the stars. The air glow fades into the growing light. The aurora becomes difficult to see. The moon turns pale and almost transparent. High clouds brighten first. Their edges become silver, then cream, then soft gold. The star is still below the horizon, yet its light has already reached the upper atmosphere. For several minutes, the clouds seem to shine by themselves. Then the first edge of the star appears. It rises through the turquoise haze as a small golden curve. The curve grows into a complete disk. Long beams of light pass through the cloud openings. They touch the lakes, hills, and quiet plains below. The indigo sky slowly returns. The moon fades into the daylight. The cloud bands continue their long journey around the planet. Another unfamiliar morning begins. Nothing needs to be remembered. The blue clouds drift on. The golden star rises, and the world turns softly beneath them. Far beyond the blue-clouded world, a hotter planet moves beneath a brilliant white star. Its upper atmosphere contains clouds made from materials that would be rock on Earth. At such high temperatures, minerals can evaporate and rise as vapor. Higher in the atmosphere, cooler air allows that vapor to condense. Tiny silicate particles gather into pale clouds. From below, they might look soft, bright, and almost familiar. Their chemistry would be strange, but their movement could remain slow and graceful. High winds stretch the mineral clouds into long silver ribbons. They cross the sky from horizon to horizon. Some layers are thin enough for starlight to shine through. Others form broad, glowing sheets above the deeper atmosphere. The white star gives each cloud a sharp edge. Inside those edges, subtle colors may appear. Tiny crystals can scatter light into faint shades of blue, pink, and gold. There is no need to remember what the clouds contain. You can simply let them drift across the bright alien sky. This planet may be tidally locked to its star. One side receives permanent daylight. The opposite side remains in endless night. Between them, powerful winds carry heat around the world. Mineral vapor rises from the hottest regions, travels toward the cooler evening side. There, it condenses into clouds and begins to fall. The particles might descend like fine, glittering dust. Deeper below, they would warm again and return to vapor. The atmosphere could repeat this cycle continuously. Rock would rise, become cloud, fall, and rise once more. From a safe distance, the process would look peaceful. Cloud patterns would form and dissolve beneath the fixed star. Near the permanent evening region, the sky could become especially beautiful. The star would rest close to the horizon. Its white light would pass through layers of mineral haze. The horizon might glow amber, peach, or muted crimson. Above it, thin clouds would shine like brushed silver. Farther toward the night side, the sky would deepen into violet and black. Bright stars could appear while the sun remained visible. Day and night would overlap across the same wide sky. If your eyes feel heavy, you can let them close. The distant world will continue turning quietly in the background. Some mineral clouds could form reflective crystals. They might make parts of the planet unusually bright from space. An observer far away could see the world change as cloud fields moved. One hemisphere might flash softly as the crystals turned toward the star. Hours later, the brightness would fade. This would not be lightning or fire. It would simply be light reflected from countless tiny surfaces. Near the cloud tops, the atmosphere might be calm. Below them, deeper winds could move much faster. The upper clouds would hide those lower layers. From above, the planet might seem smooth and quiet. Only slow ripples would reveal the motion beneath. At night, the mineral clouds would lose their bright white color. They might become dark gray silhouettes against the stars. A nearby moon could illuminate their upper edges. Each cloud would gain a thin silver outline. The moon itself might appear distorted through the hot atmosphere. Its shape could tremble slightly near the horizon. As it climbed higher, the disk would become clearer. A broad halo might form around it. Different crystal shapes could produce unfamiliar rings and arcs. Some would look like curved lines suspended in darkness. Others might resemble faint pillars extending above and below the moon. These patterns would shift as the clouds changed position. No shape would remain for very long. On the permanent night side, cooler temperatures could create thicker cloud layers. The sky might become completely covered. Stars would vanish behind a dark ceiling, yet the atmosphere could still hold a faint glow. Chemical reactions might produce dim blue or violet light. High above, auroras could brighten the cloud tops. Their colors would spread through the haze. Instead of sharp ribbons, the aurora might appear as a broad, luminous patch. It would slowly brighten, soften, and fade again. For anyone beneath the clouds, the night would seem gently illuminated from within. There would be no visible source, only a quiet glow moving across the sky. Closer to the twilight region, openings might appear in the cloud cover. Through them, stars would return. The fixed star would remain below the horizon, but its light would reach the highest clouds. Their distant edges would shine with a copper glow. The lower sky would stay dark. Above it, silver mineral clouds would float between sunset and night. The story will keep moving softly in the background. You can let each unfamiliar color pass without holding it. Farther toward the bright side, the fixed star slowly becomes visible again. At first, only its glow appears through the haze. Then a small white edge rises above the horizon. Because the planet is tidally locked, this is not a true sunrise. The traveler has simply moved from darkness toward light. With every step eastward, the star climbs slightly higher. Clouds become brighter. The ground changes from shadow to warm copper. Eventually, the star rests above the landscape. It will remain there, almost motionless. The mineral clouds continue circling the planet. They carry vapor from the bright side toward the dark. They gather, glitter, and dissolve. Nothing in this sky needs to hurry. The white star remains steady. The silver clouds drift onward. And the distant world keeps its endless, quiet evening. Beyond the mineral clouds, a colder world circles beneath the faint light of a distant orange star. Its atmosphere is thick with pale hydrocarbon haze. The star appears as a small amber disk, softened by many layers of floating particles. Daylight never becomes bright here. Instead, the landscape rests beneath a dim golden glow. The sky has no clear blue above it. It deepens gradually from amber near the horizon to dark brown overhead. Distant hills fade into the haze long before they reach the edge of sight. A nearby lake reflects only a blurred patch of light. Its surface looks dark, smooth, and almost metallic. There is no need to hold on to every detail. You can let the golden sky drift quietly past you. Clouds form high above the surface. They are thin, wide, and difficult to see against the surrounding haze. Some may contain methane droplets. Others may be made from more complex organic compounds. Their shapes change slowly in the weak sunlight. Because the atmosphere is dense, the star's light scatters in many directions. Shadows become soft and shallow. Even at midday, the ground may look as though evening is approaching. Sunrise begins long before the star appears. The eastern horizon brightens from brown to copper. Then a broad amber glow spreads upward. Only later does the star itself become visible. It rises as a muted orange circle with no sharp edge. The haze surrounds it like a wide, luminous veil. Morning arrives without any sudden change. The darkness simply becomes thinner. If your eyes feel heavy, you can let them close. The quiet orange light will continue rising on its own. At sunset, the same process unfolds in reverse. The star lowers slowly into the thick atmosphere. Its disk becomes wider and dimmer near the horizon. For a while, it seems to dissolve rather than set. The sky remains golden after the star disappears. High layers continue scattering light from beyond the horizon. Twilight may last for many hours. During this long evening, faint stars begin to appear overhead. Near the horizon, however, the haze hides almost everything. Only the brightest planets shine through. A large moon might rise as a dark reddish circle. Its light would struggle through the atmosphere. A wide halo could surround it, blending softly into the amber night. The moon's surface features would be difficult to see. It would seem more like a glowing lantern behind fog. Occasionally, rain might fall from the high clouds. On a very cold world, it may not be water. Methane or another liquid could gather into drops. The rain would darken the ground and disturb the quiet lakes. From far away, the surface would ripple beneath the orange sky. Afterward, low mist could form above the warmer liquid. The haze, clouds, and mist would merge into one soft landscape. At night, the upper atmosphere might glow faintly. Chemical reactions could produce dim blue or green light. Through the golden haze, those colors would appear muted and strange. A pale band might hover above the horizon for hours. It would not move like an aurora. It would remain almost still. Following the curve of the planet, the story will keep moving softly in the background. You do not need to remember what fills the clouds. Imagine only the quiet lake, the amber haze, and the distant orange star. The sunset has already faded. The moon rises slowly through the mist, and the cold alien night settles gently over the shore. Far beyond the amber lake, another planet turns beneath a sky crossed by enormous rings. From the surface, the rings stretch from one horizon to the other. They are made from countless pieces of ice, dust, and dark stone. Together they appear almost solid. In daylight, the brightest sections shine like a pale silver road. Fainter bands lie between them, soft and gray. Some gaps look narrow. Others open wide enough for stars to appear through them. The rings do not look the same from every place on the planet. Near the equator, they may appear as a thin line overhead. Farther north or south, they spread into a broad arch. They could fill a large part of the sky. There is no need to remember their shape. You can simply let the silver bands rest quietly above the landscape. The planet circles a calm yellow star. Its atmosphere gives the daytime sky a soft blue-green color. The rings appear brightest when the star stands behind the observer. Their icy particles reflect warm sunlight toward the ground. At other times, the rings become darker. The star illuminates them from behind, turning them into a translucent veil. Fine particles scatter the light. A faint glow forms around the darker bands. Through a telescope, the rings would contain thousands of delicate structures. From the ground, they would seem smoother and simpler. Distance would blend the separate particles into wide flowing lines. As the planet rotates, the rings remain fixed in the same great plane. The landscape turns beneath them. Mountains pass slowly under the silver arch. Oceans reflect broken pieces of it. Clouds drift across the view, hiding one section and revealing another. A storm far away might erase the rings for several hours. Then the clouds would thin. The bright bands would return, unchanged and patient. At sunset, the yellow star sinks beneath the ring system. For a moment, sunlight passes through thin regions of ice and dust. The sky fills with long beams. Some are pale gold, others appear rose, amber, or faintly blue. Dense parts of the rings create dark shadows. These shadows stretch across the atmosphere like enormous ribbons. From the ground, sunset may seem divided into alternating bands of light and shade. The star moves behind one ring. Daylight dims. Then it enters a gap, and the horizon brightens again. This pattern may repeat several times before night arrives. The sunset would not be one smooth fading. It would come in gentle steps, bright, dim, bright again, and then slowly dark. If your eyes feel heavy, you can let them close. The last light will continue moving through the rings. After the star sets, the rings remain visible. Their far side still catches sunlight. They glow above the dark landscape like a quiet bridge. One section disappears inside the planet's shadow. The rest stays silver. The shadow moves slowly across the ring plane as the night continues. Stars shine clearly between the bands. Some are hidden behind the brightest ice. Others appear through the darker gaps. A moon may travel close to the rings. It moves like a small white bead beside the enormous arch. Its gravity helps shape some ring edges. Tiny moons can keep gaps clear or gather particles into narrow bands. These are sometimes called shepherd moons. Their motion is slow from the surface. A careful observer might notice their positions changing from night to night. The rings could also brighten the ground. On a clear night, they might cast faint shadows. Trees, rocks, or unfamiliar plants would appear as dark shapes beneath silver light. Near the equator, the ring line could divide the sky exactly in two. Constellations above it would seem separated from constellations below. The line would remain steady while the stars moved around it. On nights without a moon, the rings might become the main source of light. Snow or ice on the surface would reflect their glow. A frozen plain could shimmer beneath the arch. Each crystal on the ground would catch a tiny fragment of the distant brightness. The story will keep moving softly in the background. You can let the stars and rings pass without counting them. During certain seasons, the rings would cast wider shadows across the planet. The sunlight would reach them from a lower angle. Large regions beneath the shadow could become slightly cooler. Clouds might form differently there. Long bands of mist could follow the moving darkness. Elsewhere, reflected ring light might brighten the night side. The planet's climate could respond to these slow changes. Yet from one evening to the next, the sky would still feel calm. Near dawn, the eastern horizon begins to brighten. The rings above it fade into the growing light. Their brightest sections remain visible longest. The hidden star illuminates high clouds first. They turn pale gold beneath the silver bands. Then the star rises through a gap in the rings. For a few minutes, its disk appears framed by two dark lines. Light spreads across the landscape. The ring shadows shorten. Stars disappear. The silver arch becomes softer against the blue-green morning. Nothing in the scene is hurried. The rings continue their silent orbit. The clouds move below them. And another alien day begins beneath the sky crossed by ice and light. Beyond the ringed horizon, countless other skies wait quietly in the darkness between stars. Some may be bright and clear. Others may be hidden beneath clouds that never fully open. A few worlds may have skies so thin that daylight never turns them blue. Their stars would shine against black space. Even at noon, the ground could be bright, while the heavens remain dark. Without much atmosphere, sunsets would be brief. The star would touch the horizon and disappear with little lingering color. Then the constellations would return almost immediately. On worlds with deeper atmospheres, evening could last for hours. Light would continue traveling through haze and cloud after the star had set. The horizon might hold a soft glow throughout much of the night. There is no need to hold on to every detail. You can let these distant skies pass slowly, one after another. Some planets may orbit stars that appear unusually large. A red dwarf seen from a nearby world could look wider than our sun. Its surface might show dark regions and brighter arcs. The star would hang above the landscape like a great red lantern. On a tidally locked planet, it might remain in almost the same place forever. Clouds would move beneath it. Seasons might change around it, yet the star itself would barely shift. Elsewhere, a distant white star might appear no larger than a bright point. It could still provide enough light to warm the world below. The sky would be shaped not only by the star's size, but by its true brightness and distance. A small-looking star could create a brilliant day. Now, a large-looking star could provide only a dim red afternoon. Some alien skies may contain several moons. One moon could rise while another was setting. A third might remain high overhead. Each would cast its own faint light across the surface. Their phases would change at different speeds. One might be full, while another appeared as a thin crescent. During certain nights, two moons could pass close together. They might overlap briefly, creating a quiet eclipse against the stars. Their shadows could also cross the planet. Daylight would dim as one moon moved in front of the star. Minutes later, the light would return. A second eclipse might follow hours afterward. To anyone living there, these changes could feel ordinary. The sky often seems magical only because it is unfamiliar. The story will keep moving softly in the background. Nothing here needs to be understood before sleep arrives. Some worlds may have no moons at all. Their nights would belong to the stars, planets, auroras, and faint atmospheric glow. Without moonlight, the sky could appear exceptionally deep. The Milky Way of that system might stretch overhead as a broad, luminous band. Dark clouds of dust would divide it into winding paths. Young stars could glow inside distant nebulae. Nearby planets might shine steadily among them. On a world closer to the center of its galaxy, the night could contain far more stars than ours. The heavens might seem softly crowded with light. There could be fewer empty spaces between the constellations. The surface might never become completely dark. On a planet far from the bright regions of its galaxy, the opposite could be true. Only a few stars might appear clearly. Large areas of the sky could remain black and still. Its nights would feel wide, quiet, and open. Neither kind of sky would be more natural than the other. Each would simply reflect a different place in the universe. Clouds might also change the appearance of the galaxy above. Thin clouds could soften the stars into glowing patches. Thicker clouds would hide them completely. Then, without warning, a gap might open. For a few minutes, the entire galaxy would become visible. The clouds would close again, and the night would return to darkness. There is no need to wait for the sky to clear. You can rest beneath the clouds just as easily. Some alien worlds may have rainbows. Whenever droplets or crystals bend and reflect light, separated colors can appear. A planet with two suns might form overlapping rainbows. Each star could create its own arc. One might look brighter and warmer. The other could appear fainter, with slightly different colors. Mineral crystals might produce pale rings rather than familiar bows. Methane droplets could bend light at different angles than water. The resulting colors might be broader, dimmer, or arranged in an unfamiliar order. A rainbow there might appear near a red sunset. It could rise from mist above a dark ocean. Its colors would remain gentle beneath the warm light. Then the mist would thin, and the arc would quietly disappear. Even the color of lightning, if distant enough to remain peaceful, would depend on the atmosphere. Different gases could create white, blue, violet, or reddish flashes within faraway clouds. From beyond the horizon, the light might appear only as a soft glow. Clouds would brighten for a moment, then the darkness would return. But tonight, there is no need to follow storms. We can remain with calmer skies. A quiet ocean world beneath a low orange star. A frozen moon watching a giant planet rise. A ringed world where silver bands cross the night. The red dwarf planet resting forever in twilight. A double star world where evening arrives twice. All of them continue moving, whether anyone is there to see them. Atmospheres circulate. Clouds form and dissolve. Moons cross the sky. Stars rise, set, or remain almost still. The universe carries on without asking us to stay awake. If your eyes feel heavy, you can let them close. The facts can become softer now. The names of gases, stars, and clouds may begin to fade. Only the colors need remain. Deep blue above a distant ocean. Copper light along an endless horizon. Silver rings above quiet snow. Violet auroras moving through a dark sky. A small red sun behind a veil of clouds. You may imagine yourself resting somewhere safe beneath one of those heavens. The ground is still beneath you. The air is calm. Nothing is approaching. Nothing needs your attention. Far above, a pale moon moves slowly between the stars. Its light touches the clouds and leaves a soft path across the landscape. The horizon holds the final color of evening. It becomes dimmer with every passing moment. The clouds lose their edges. The stars grow quiet and distant. Even the largest planets seem gentle from far away. There is no need to wonder which of these skies truly exists. Many possibilities are still waiting to be discovered. Some may resemble the worlds we imagine tonight. Others may be stranger, softer, and more beautiful than anything we can picture. For now, the unknown can remain unknown. You do not need to travel farther. You do not need to remember the 100 strange skies. They can continue turning without you. The red stars will keep glowing. The double sunsets will keep fading. The mineral clouds will keep drifting through unfamiliar air. The auroras will keep following invisible magnetic paths. And somewhere, on a world no telescope has yet seen, a quiet sunrise may already be beginning. Its first light reaches the highest clouds. A thin line appears along the horizon. The sky slowly changes color, but you may remain here in the darkness. The story has carried you far enough. Let the last distant sky fade softly into the background. Let every star grow dim. Let every cloud drift away. And let the universe continue its quiet journey while you rest.